A cracked windshield feels like a simple problem with a simple fix: remove the broken glass, glue in a new one, done. And that's exactly why so many replacements look perfect from the outside, yet a week later you're chasing a damp smell, a mysterious whistle at highway speed, or worse, a windshield that isn't really bonded the way it needs to be when the car flexes in a pothole or a crash. The scary part is that the failure can be invisible. The bead can look fine at the edges, the trim can sit flush, and still the bond line has gaps, contamination, or the wrong height. That's what makes this job trickier than it seems. If you search for windshield replacement on Suzuki Swift, you're probably in one of two situations. Either you want to do it yourself and you need the real workflow, not the just cut and stick version. Or you're hiring a shop and you want to know what good looks like so you can spot shortcuts before they become leaks, rust, or wind noise. The Suzuki Swift is a straightforward car in many ways, but the windshield area still has all the same rules as any modern unibody. The glass is part of the structure, the seal is created by urethane chemistry and bead geometry, and the water management depends on trim pieces being seated correctly. Start with the decision you don't want to make, DIY or professional. If you have a clean workspace, patience, and you can follow product instructions exactly, a careful DIY install can be done. But if your Swift has a forward-facing camera, rain/light sensor, special acoustic glass, a heated area, or any trim you're not confident you can remove without breaking, the risk climbs fast. Not because the glass is high-tech, but because one wrong part or one damaged clip can turn into a water routing problem that looks like a bad seal. Also, if you can't keep the car parked long enough for the urethane to reach its safe drive-away time, you're gambling with the bond. Before you touch a tool, confirm what windshield you're actually replacing. Suzuki Swift generations and trims vary by market, and the glass can differ by tint band, mirror mount style, sensor bracket, and molding design. The most painful mistake is discovering incompatibility after the old windshield is already out. So you verify the glass matches your car's features, and you check whether the new windshield comes with the correct brackets already attached. Some brackets are meant to be bonded at the factory, moving them is possible but it's a precision job, and if you get the position wrong, sensors and cameras can misbehave. Now, tools and materials. The job is less about having a huge toolbox and more about having the right consumables. You need an automotive windshield urethane designed for structural bonding, and you need the primer system that matches it. This is where people ruin the job with one purchase, using silicone, household sealant, or a random weatherproof adhesive. Those products are not designed for the loads, the temperature cycles, or the crash requirements of a windshield bond. Proper urethane is also sensitive to contamination, and the primers are not optional decoration. They're part of the chemical handshake between glass, paint, and adhesive. You also need a way to cut out the old windshield. There are a few common methods. A wire cutout system uses a strong wire to saw through the old urethane. It's slower, but it gives you control and can reduce the chance of gouging paint if you're careful. A cold knife can be faster in experienced hands, but it's also a great way to slip and carve the pinch weld, which is the metal flange the glass bonds to. That flange is everything. Damage it and you invite rust. Rust under the bond line is like cancer, it spreads quietly, lifts the urethane, and months later you're dealing with bubbling paint and leaks that no amount of extra sealant will fix. Plan your workspace like you're doing surgery, not a weekend craft. You want a dry area, minimal dust, and a temperature range that matches the urethane's label instructions. Urethane cure behavior changes with temperature and humidity. People love to treat cure time like a vague suggestion, I'll wait an hour. But the only time that matters is the product's safe drive-away time under your conditions. That's the point where the windshield is retained well enough for normal driving and airbag deployment assumptions. Full cure takes longer, and you should treat the car gently until then. When you're ready to start, protect the interior and the paint. Broken glass loves to hide in defroster vents and along the dash edge. Cover the dash, and be careful around the A-pillar trims. On many cars, those trims interact with airbags. You don't want to yank, twist, or break clips and then reinstall something that rattles or interferes with proper deployment. If you're not sure how your Swift's trim is retained, slow down and research that exact trim style before you pull. Remove the wiper arms and the cowl panel at the base of the windshield. This is where a lot of mystery leaks are born. The cowl isn't just cosmetic, it manages water flow. If it's cracked, warped, or not seated, water can pour into places it shouldn't, and you'll blame the glass. As you remove moldings and clips, pay attention to what's reusable and what's not. Some reveal moldings are designed to be replaced. Some clips lose tension after removal. Reusing a damaged molding can create a gap that whistles at speed, even if the urethane bond is perfect. Now the cutout. The goal is to separate the glass from the car without bending the pinch weld and without scraping paint to bare metal. Work slowly around the perimeter. Corners are the danger zones because the angle changes and the tool wants to jump. If you're using wire, keep it tight and controlled and protect the dash edge. If you're using a knife, keep the blade angle shallow and respect how close you are to painted surfaces. Once the old windshield is out, don't rush to clean everything to shiny metal. That's another common misunderstanding. You're not trying to remove all the old urethane. In most professional workflows, you trim the old urethane down to a thin, even layer. That remaining layer becomes a good bonding surface for the new urethane, as long as it's clean and sound. If you scrape down to bare metal everywhere, you create a bigger corrosion risk and you add steps. Now you must properly treat and prime exposed metal. The best outcome is a consistent, stable base. This is the moment where the job is won or lost. Pinch weld conditioning. Inspect the entire flange. If you see surface rust, you need to decide whether it's light enough to treat or whether it's advanced enough that the metal is compromised. Light surface rust can sometimes be addressed with proper cleaning and an appropriate primer system, but if rust has pitted the metal, lifted paint, or spread under the old urethane, you're not just doing a windshield anymore. You're doing body repair. And if you ignore it and glue over it, the new windshield may seal today and fail later, because the urethane is only as strong as what it's bonded to. Cleanliness matters in a boring, unforgiving way. Oils from fingers, dust, old glass fragments, and even certain cleaners can interfere with adhesion. Use products intended for automotive glass prep. Avoid leaving lint. Don't touch the bonding area after it's prepped. If you do, you clean it again. It feels obsessive, but it's cheaper than redoing the job. Before any adhesive comes out, do a dry fit. Set the new windshield in place without urethane and confirm it sits correctly. Check the edges, the top corners, and the way it meets the A-pillars. This is also when you plan your alignment references. Professionals often use small reference marks so the glass lands exactly where it should on the first set. Because once urethane touches, you don't want to slide the windshield around like you're adjusting a picture frame. Sliding can smear the bead, create thin spots, and trap contamination. Now we are at the part everyone thinks is just apply glue, but it's really the engineering core of windshield replacement on Suzuki Swift. The urethane bead is not simply a seal, it's a structural adhesive joint. The bead needs the right height and shape so the glass compresses it properly. Too low and you get gaps, wind noise, and weak retention. Too high and the glass can sit proud, trim won't fit, and you can create stress points that lead to cracks. The bead must be continuous, especially at corners. A tiny break in the bead at the top corner can become a leak path that only shows up in heavy rain or a car wash, and it can be maddening to diagnose later. Primer rules are where DIY jobs often go off the rails. Some urethanes require primer on the glass frit band, some require it on the pinch weld, some require both, and some have specific, no primer on old urethane, guidance. You don't guess. You read the technical instructions for the exact urethane and primer you're using. And you respect flash times. Primer needs time to do its job. If you apply urethane too soon, you can trap solvents. If you wait too long, you can miss the bonding window. This isn't about being fancy, it's about chemistry. When you're ready, cut the urethane nozzle to the correct opening. The cut angle and opening size control bead shape. A common mistake is cutting too small because it feels neat. Then you end up with a skinny bead that can't fill the gap. Another mistake is stopping and starting, creating overlaps and voids. You want a smooth, consistent bead all the way around. If you have to pause, you plan your restart so it overlaps properly without leaving a channel. Set the windshield with help if possible. Even a small windshield is awkward, and the risk isn't just dropping it. The risk is bumping the bead, smearing it, or setting the glass slightly off and then trying to nudge it into place. Use suction cups if you have them. Lower the glass in a controlled way, align to your reference marks, and set it down once. Then apply gentle, even pressure around the perimeter to ensure contact. Not pounding. Not leaning your whole body weight. Just firm, consistent seating. Watch for squeeze out. A little squeeze out can be normal, but excessive squeeze out can mean your bead was too large or the glass is sitting too low. If urethane gets where it shouldn't, clean it the right way, with the right cleaner, before it cures. Don't smear it across paint or headliner fabric. And don't use aggressive solvents that can damage finishes. Reinstall moldings and the cowl carefully. This is another place where people accidentally create leaks. The windshield bond can be perfect, but if the cowl isn't clipped in, water can run into the cabin air intake area or down the firewall in a way that mimics a windshield leak. Make sure the wiper arms go back in the correct park position. A mispositioned wiper can hit the edge of the hood or the A-pillar trim and create a whole new problem. Now, the hardest discipline, leaving it alone. Fresh urethane doesn't like door slams. When you close a door with the windows up, cabin pressure spikes and can push on the uncured bead. That can create micro gaps at the top edge that later become wind noise. So for the early cure period, close doors gently and, if possible, crack a window. Avoid driving too soon. Avoid rough roads. Avoid washing the car. And don't remove any retention tape early if you used it to hold position, unless your urethane instructions say otherwise. Safe drive-away time is not a vibe. It's a number on the product sheet, and it depends on temperature and humidity. If you can't meet it, you wait. If you absolutely must drive, that's a sign the job should be done by a shop that can use a fast cure system and control conditions. Also, if your Swift has any camera-based systems, you may need calibration after replacement depending on the system design and local requirements. Sometimes the camera bracket position and glass geometry are enough to keep it happy, sometimes it needs a recalibration procedure. The point is, you don't want to discover this after everything is back together and the dashboard is lighting up. After the urethane has had adequate time, you verify. Don't skip verification just because it looks good. Start with a visual inspection from inside and outside. Look for uniform contact, no obvious gaps, and trim sitting correctly. Then do a controlled leak test. The safest approach is gentle water flow, not a high-pressure jet aimed at the edges. High pressure can force water into places it would never go in real rain and can also disturb trim. You're looking for consistent sealing under realistic conditions. If you see water, you don't immediately assume the urethane failed. You trace where it's coming from. Water can travel along trim, clips, and body seams before it shows up on your carpet. Wind noise diagnosis is its own art. A whistle at speed often points to a small gap at a corner or along the top edge, or a molding that isn't seated. A low-frequency roar can be a larger gap or a misaligned glass position affecting airflow. If the noise appeared right after replacement, it's almost always installation-related, but not always the adhesive itself. Sometimes it's the cowl, sometimes it's a missing clip, sometimes it's a molding that got stretched or kinked. If something is wrong, the temptation is to seal the edge with extra goop. That's how you turn a fixable problem into a mess. Edge sealing with the wrong material can trap moisture, accelerate rust, and make a proper redo harder. If the issue is a molding not seated, fix the molding. If the issue is a water routing problem at the cowl, fix the cowl. If the issue is a true bond failure, the honest answer is that the windshield may need to come back out and be redone correctly. It's painful, but it's safer than trusting a compromised bond. Here's what a hidden failure often looks like in real life. The car is fine for a few days. Then you notice fogging on the inside on humid mornings. Or you smell damp carpet. Or you get a faint whistle only when a crosswind hits. Those are early warnings. Another warning is rust starting at the edge under the molding months later. That usually means the pinch weld paint was damaged during removal and not properly treated, or water is getting in and staying in. Once rust starts under the bond line, it doesn't stop because you wish it would. If you're hiring a shop, you can still use this knowledge. Ask what urethane system they use and whether they follow the manufacturer's safe drive-away time. Ask how they handle pinch weld damage and rust. Ask whether they replace one-time use moldings or clips if your Swift uses them. A good shop won't be offended by those questions, they'll answer them clearly. A shop that gets defensive or vague is telling you something. And if you're doing it yourself, the real win is not speed. The win is controlling the variables you can control: correct parts, correct prep, correct bead, correct cure. That's how you prevent the weird outcomes where everything looks perfect but behaves wrong. So when people say windshield replacement on Suzuki Swift is easy, they're not completely wrong about the physical act of putting glass in a hole. The part they miss is that the windshield isn't just glass. It's a bonded structural component, a water management boundary, and a noise barrier. The difference between a clean, quiet, safe install and a frustrating, leaky one is usually one small shortcut you didn't think would matter: a fingerprint on the bonding area, a bead that thins at a corner, a rush cure, a nicked pinch weld left untreated, or a cowl clip that didn't click. If you take one idea away, take this: the windshield doesn't seal because it's tight. It seals because the adhesive system is compatible, the surfaces are prepared correctly, and the bead geometry is right. Do that, and your Swift will feel factory again. Skip it, and you'll be chasing symptoms that don't make sense until you realize the problem was baked in on day one. And when you're done, don't just celebrate that the glass is in. Verify it. Drive it after the proper time. Listen for noise. Check for moisture after the first rain. Because the whole point of windshield replacement on Suzuki Swift isn't just seeing clearly through new glass. It's knowing the car is sealed, quiet, and structurally sound in the ways you can't see.